Alright guys, let's talk about something huge, the energy demands of artificial intelligence. We're not just talking about your average laptop anymore. We're talking about gargantuan language models, swallowing energy at an absolutely incredible rate. Think about ChatGPT, powered by GPT-4. To answer those hundreds of millions of questions daily, it gobbles up more than 17,000 times the electricity of your average American household. And that's just one model. The energy consumed to train and run these AI models is mind-boggling. A McKinsey report highlighted that by 2030, these systems could be powering 11 to 12% of the entire U.S. power demand. That's a staggering leap from today's 3 to 4%. This explosion of AI compute means that data centers, the powerhouse behind these AI tools, are projected to create a massive surge. But here's the kicker. To meet this short-term need, many big players have been turning to fossil fuels, and that shoots up greenhouse gas emissions. For instance, Google's carbon emissions jumped by 48% in 2023, largely because of the intensified data center energy requirements. So, we're not just talking about efficiency here. We're facing a full-blown energy crisis that's being driven by AI advances. This isn't sustainable, right? Think about the broader climate implications. We're talking about a planet already struggling with rising temperatures and extreme weather. The sheer scale of the AI energy issue is only going to worsen this. Let's visualize this with some actual figures. The amount of energy these AI models are taking is astronomical. Think terawatts of energy being consumed worldwide. This isn't some far-off tech scenario. This is happening right now. So what it's all pointing to now is we need a solution. And fast. Because without a breakthrough in renewable sources quickly enough, there's no way AI progress will be able to happen, or will not happen in any way that's sustainable. What's all this mean? It means we aren't moving just toward net zero goals. We're en route to a serious clash between AI's progress and environmental responsibility. I know I feel anxious about this for a number of reasons. This is really something we need to grapple with altogether now. So, what are some of the actual answers that are being tried right now? Well, here's the thing. Renewables like solar and wind are amazing, truly. I mean it. But the reality with large-scale AI is that they just aren't cutting it. The energy generated by these sources is intermittent. It only produces power when the sun shines or the wind blows. The current energy storage methods have limitations. We're just simply not at a stage where batteries, for example, can adequately support AI's insatiable urge for power. This is why many tech leaders are facing that stark reality. Large-scale AI is just not compatible, at least in this moment, with what renewables are able to deliver. Let's look at something very precise. Right now, renewable energy sources might constitute as many as 9% of total U.S. energy consumption. Even if we doubled this and tripled it and quadrupled it, we're not touching that current 83% dominance held by fossil fuels. That's why this is so critical. We aren't just talking about environmental catastrophe here. Although we are talking about environmental catastrophe, we are also talking about the future of AI itself. I mean, if AI can't be powered sustainably, then what is the point of investing in it to begin with? There aren't clear answers, and the entire field is grappling with this. But that means we need to consider all possible solutions. What are some of the actual technical considerations here? Well, there are lots of problems to address, ranging from finding materials that are both sustainable and productive to overcoming technological hurdles such as the inefficiencies of transforming solar and wind power into stored energy. This issue is what's driving the ongoing momentum around nuclear energy. Now let's get into the really interesting part, the surprising comeback of nuclear energy. There are concerns, I know, obviously, but hear me out. It's a carbon-free method of generating electricity that can supply the scale of energy that AI demands. Think about this. Nuclear plants require far less land than renewable energy farms. In California alone, a solar farm needs 450 times more land to generate the same energy as a single nuclear plant. And that's before considering storage. We also have to consider the scale of materials needed. Nuclear power plants require far less materials and produce much less waste than solar and wind farms. The benefits are clear, but so are the risks, like radioactive waste and safety concerns. A lot of the technology is still quite old, and there have been accidents, yes, but look at this. The industry is still innovating. There are new reactor designs that offer the potential of being cleaner, safer, and more economical than existing ones. Let's compare countries. Germany relies heavily on fossil fuels and renewables, but still pumped out more than twice the CO2 emissions versus France, which gets 70% of its power from nuclear. That's a colossal difference. It shows us, starkly, that nuclear technology can be an extremely effective tool for lowering carbon emissions and combating climate change. Many tech leaders have embraced that view. For example, Sam Altman, the brains behind OpenAI, invested heavily into Helion Energy, a leading firm dedicated to nuclear fusion technology. Also, take a look at OpenAI's plans are to use nuclear power. He is also investing in other nuclear ventures, highlighting a growing acknowledgement of the role that nuclear energy will play in powering AI's future. And we should see that as a really good thing. Of course, the success of any plan to scale up nuclear will also depend heavily on government support. The Biden administration, for example, committed in 2024 to invest heavily in next-generation nuclear technologies. This is a game-changer because it sends a message to the industry and to investors that there's ongoing support, creating opportunities for developing safer and more efficient solutions. This is extremely important because for any industry to continue to improve, we must always make our own efforts to invest time and money in upgrading the technology and fixing any of the existing limitations. What's all this look like in practice? The commitment translates to significant funding and an incentive for private investment in R&D, which will provide the engine for improvements to existing technology. This could mean everything from boosting safety standards, reducing costs associated with waste treatment, and increasing efficiency, meaning better overall energy output. With such progress in clean energy technologies as well, even if we use existing nuclear reactor designs, that could help us make massive progress. We aren't thinking just about using existing reactors. We're thinking about improving them and designing new, safer, and far more advanced technologies. But it's not just about the technology itself, it's also about having a plan. The challenges that AI demand brings to the energy sector mean that governments and other leaders need to be thinking holistically, from the planning stages of development of new power plants to the long-term management of associated waste. But look at this. The whole field is rapidly evolving. At a time when the world is focused on finding answers to climate change and global warming, nuclear energy is not only positioning itself as a realistic and achievable option, it's also becoming the solution that is both economically and environmentally sound, given the increasing capacity of AI. This is why so many are coming to embrace it with such enthusiasm. And I think that's really, really awesome. Look at it this way. The future of AI is literally at stake. It is not going to exist in a meaningful way without a significant shift towards more energy-efficient technologies and sources. And given the capacity of nuclear power to address this shortfall, it's a cause many people have been increasingly rallying around, and for good reason. I really hope that we will be able to find solutions that are both ecologically and economically viable, not because it will make our technologies better, but because our planet's well-being depends on it.